Thank you very much. I'm quite excited to be here because I would classify myself as a software engineering researcher, and pathology is still quite new to me. I started working at Haukeland University Hospital in Bergen, Norway, last year in January, and I'm working in this project with the abbreviation PIV, and they're doing mostly digital pathology with images and so on, but I'm doing something different. I'm doing workflow modeling and optimization. So when I started with this, so when I told my parents first, they thought, oh, pathology, you're working with dead bodies now? Well, it's, for the Germans, there's like a crime series and everybody thinks it's just about forensic pathology. But I learned it's of course much more, and it's mostly colorful images. So now I explain it like pathology is a box, you put a specimen in, and at some point you get the diagnostic report out. Now you might say, oh, this is way too abstract. Of course it is, so let's make it a bit more detailed. So there's usually, you have two parts. You have the lab that produces the slide, and then the pathology looks at it in a microscope and gets the report out of it. And now everything has become a digital, so you scan the slide in, so I guess that's why you need a digital pathologist now, and we're having this conference. And for that part, of course, there's many tools. You have machine learning, deep learning to assist the pathologist, but how can we assist the lab? Can we get a tool that helps us? How many lab technicians I need at that station? What pathologist should get what case? Well, maybe there is something. It's actually the good old-fashioned, the good old age of AI, where everything was about logic and less about machine learning. And they developed like logical agents that could like solve problems like stacking blocks on a table or making a flight schedule plan. And it's based on optimization, which also used in machine learning. And reinforcement learning kind of got a little bit of a renaissance now with AlphaGo, and it's used in deep. You can use deep neural networks as well there. But all of this is kind of based on the fact that you need a quite formal declaration of your world, and ideally also a cost function so that your agent knows how good he's doing. And so how do we get this model? And I mean model by a simplified version of reality. So there's actually a research field called process mining, where you look at just events and try automatically create a process model. But for pathology, it's pretty well known what's happening. So what we did, I just did an internship at the lab and learned how to use a microchrome and so on. And I came up with this. So this is the histology workflow. So now it's a bit weird that a computer scientist explaining to pathologists how the workflow works, but just bear with me. So the specimen comes in, gets grossed, so you get like some cassettes out with the tissue in it. Then in big batches at night you process it, then the processed tissue gets put into the paraffin, and then you cut the block where you get the slide first, and the second one too. And then you stain them, and then now with the digital pathology, another step comes in, the scanning. So from the technical side of view, this just adds more time, everything gets a bit slower, but so then it gets to the pathologist who starts writing a report, and maybe he's not quite sure, so he gets back, so he needs to maybe retrieve the slide again, cassette again, create another slide with a different stain, and then goes on same way, and then hopefully this is enough to be done. So there's a loop, so it could go on forever, but we hope we get a fixed point of confidence at some point so that this goes on. And now I can tell you that this is almost enough to tell a computer what is going. Because if I just change a little bit notation, looks like this, and this is called a Petri-net. So just short digression, what is a Petri-net? It's nothing to do with the Petri dish or fishing or so on, it's just named after this guy. And it has circles, they're called places, they are passive. So then there are the black boxes that are transitions, that's something that happens. And you have the arcs that connect places to transitions and the transitions to places. And then you have the tokens that represent something lying in the place. And what can happen is that the transition fires and then the token moves to the next place. And this is pretty much what's happening in the lab, right? So when I have this Petri-net, what I can use it for? Well, you can use it for many things. You can use it for dashboards, like reports, live reports, simulation, then predictions and other cases. So what does it mean? So of course the Petri-net alone is a bit anemic, but what we do is we extract event data from our laboratory information system, just what happened when, and then we replay the events happening on the lab, and then you can see, okay, what's happening right now. And first of all, we used it to create a dashboard that in live shows you, we just implemented it this week, so the lab technicians can see how many cases have we grossed so far, and how many sections are coming in, and so on. And when we have that, we can of course measure it, make statistics, and then we know, okay, this in these cases takes so and so many time at this station. So we can use that for doing simulation. And when you have simulation models, you can play around with configurations like, let's see so many cases come in today, and I have so and so many lab technicians. So this is just resource configuration, but of course you could think also that you can just do fundamental changes, change the net a little bit. Now with digital pathology, what happens if these cases get like kind of automatically analyzed by these AI tools? So when you have this configuration, then you just play run, and then you can see some hours of the labs going on, and then you see, how many tokens are lying around in what case. And when this has happened, then you can of course measure what had happened. And then you see, are there bottlenecks? Are some stations taking too much time? Is there something I have to adjust maybe? And I can predict what is the average turnaround times for this type of case. And this then, again, coming back to the optimization part, could be used for getting a cost function, but you can also have new use cases. Probably you can have something for the patient that he can just track it like a DHL package, like, how much time you have to wait on the specimen to leverage this waiting time that patients find quite horrible. Well, yeah, this is what you can do with it. Some challenges why it's of course taking always more time than you would think it would take. First of all, access to our data, even if it's just if you have a data management plan and it's all anonymized and it's just the production data basically, it's still hard to get through bureaucracy to access your LIS for that. Then the pathology domain is a bit like not really standard distributed, so there's always things happen, there's a big variety, and we have few resources to do all that. So, which basically brings me to the end. I'll be around today, so just talk to me, and there's also our email. You can Google our project, and yeah, we're also trying to release all the code that we are developing on GitHub, so it's open source. So as soon as we have it going kind of with our LIS, and then you can just plug in the event data of your LIS and maybe try what's happening. So thank you very much.
Very inspiring talk. It's next generation business analytics for
pathology.
Very amazing. Any questions?